Hello, listeners. As an enhancement to your listening experience, I am now going to present these archive episodes unedited in their entirety, which includes all of my afterthoughts. So, continue listening after the outro music if you want to hear what I thought of the episode. And if you are enjoying the podcast, please support it by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. And now I can also accept Zelle and Venmo. Just use my email address, spacerockethistory@gmail.com. Thanks. Hello and welcome. This is Michael Annis, and you're listening to episode 234 of the Space Rocket History Podcast. And now, Soyuz 6, 7, and 8, Part 2, the Vulcan device. Continuing from last week, Soyuz 6 and 7 are in Earth orbit, and Soyuz 8 is being prepared for launch. It is October 13th, 1969. But before we launch Soyuz 8, let's meet the brave cosmonaut crew. The commander of Soyuz 8 was Vladimir Shatilov. He was born in 1927 in Petropavlovsk, North Kazakhstan Oblast. He graduated from Kachinsk Military Pilot School in 1949. He graduated from Monino Military Academy in 1956. He earned his technical science degree in 1972. He was married and had 2 children. He was selected as a cosmonaut in 1963, and he went through cosmonaut training from January 63 to January of 65. After completion of his basic training, Shatilov was initially assigned to Voskhod 3, but that flight was canceled just 10 days before launch. Chief designer Korolov's successor, Vasily Mishin, canceled Voskhod 3 because he wanted to concentrate on Soyuz. Soyuz 4 was Shatilov's first of 3 flights. Soyuz 8 was his second flight, and Soyuz 10 was his last. After his cosmonaut career, Shatilov succeeded General Kamanin as commander of cosmonaut training from 1971 through 1987. Eventually, he was made the aide to the Commander-in-Chief of the Air Force. He retired from cosmonaut-related duties in September 1991 and from active duty in the military in 1992. As of November of 2017, he is still living. The second member of the crew was Alexei Yelizhev. He was the flight engineer. Alexei was born July 13, 1934 in Zhizdra, Kaluga Oblast, with the name Alexei Karaitis. Alexei's father was Lithuanian, and he was arrested and sent to a gulag in 1939. So in 1950, Alexei took the maiden name of his mother, Yelizhev. Therefore, some regarded him as being a Lithuanian cosmonaut. Yelizhev graduated Bauman Higher Technical School in 1957 and earned his postgraduate degree from the Moscow Institute of Physics and Technology in 1962. He eventually earned a doctorate of technical science in 1973. Yelizhev initially worked as an engineer in Sergei Korolov's OKB-1 Design Bureau before being selected for cosmonaut training in May of 1968. Soyuz 5 was his first of 4 flights. During the Soyuz 5 flight, he walked in space to Soyuz 4 and returned to Earth in it. So, he flew in Soyuz 5, 4, 8, and 10. In 1985, he retired from the space program and began an administrative position at the Bauman School for several years before retiring fully. As of November 2017, he is still living. Now that we have met the crew, we will move ahead to the launch of Soyuz 8. Almost 24 hours after Soyuz 7, on October 13, 1969, the Soyuz 8 was launched with spacecraft commander Shatilov and flight engineer Yelizhev. At T plus 118 seconds, the side boosters were dropped. At T plus 160 seconds, the shroud and the escape tower were jettisoned. At T plus 300 seconds, the core stage separated. At T plus 540 seconds, the upper stage separated. At T plus 583 seconds, Soyuz 8 entered orbit, just like Soyuz 6 and 7. The initial apogee was 223 kilometers, which was 3 kilometers lower than Soyuz 7. The perigee was 205 kilometers, which was 2 kilometers lower than Soyuz 7. The angle of inclination was 51.7 degrees, the same as Soyuz 7. The period of revolution was 88.6, the same as Soyuz 7. 36 minutes later, the Soviet Union announced the launch of Soyuz 8. With all three spacecrafts now in orbit, it became a joint mission of Soyuz 6, 7, and 8. There were plans to get Soyuz 7 docked with Soyuz 8 and transfer at least one cosmonaut by a spacewalk, while Soyuz 6 took video from nearby. But a confirmation about a planned spacewalk was never given. During the joint flight, two types of maneuvers were executed. The first type was automatic, carried out by the Ground Control Center. In this case, all the data concerning the orbital parameters of the spacecraft were obtained by ground facilities, and the Control Center then issued orders supplying all the necessary data on the magnitude and direction of the correcting thrust, which were needed to maneuver. In this type of operation, the cosmonauts often did not even see the other spacecraft. The second type of maneuver was carried out manually on the basis of autonomous navigation. The Control Center did not intrude or participate in this type of maneuver. The cosmonauts made their own decisions as to what to do in order to carry out maneuvers using only onboard facilities and inter-spacecraft communications without any assistance from the ground facilities. In the course of the mission, more than 30 maneuvers were carried out. Most of these were carried out manually on the basis of autonomous navigation. The Soviets used two basic methods of autonomous navigation. The first method was based on terrestrial orientation points, while the second was based on the measurement of position of certain stars in relation to the horizon of the Earth. To accomplish autonomous navigation, the Soyuz spacecrafts were equipped with optical sighting devices, shadow indicators, ionic sensors, computers, and other instruments. The first rendezvous attempt occurred about 24 hours after the launch of Soyuz 8 on October 14th. The plan was to let Soyuz 8 dock with Soyuz 7 while Soyuz 6 observed from about 50 meters away. This was similar to the successful docking procedure of Soyuz 4 and 5 in January of 1969. Soyuz 7 was the passive craft and Soyuz 8 was the active craft. The orbital maneuvers calculated from the ground brought Soyuz 8 to within 1 kilometer of Soyuz 7, but the EGLA automatic rendezvous system failed to provide a lock-on between the two craft. The two craft drifted apart to 3 kilometers distance before Mission Control decided that the crew of Soyuz 8 could perform the rendezvous manually but only if the range was within 1.5 kilometers. Since Soyuz 7 and 8 were already 3 kilometers from each other, it was decided another try would be made the following day. After an orbital correction during the night of October 14th, Soyuz 7 and 8 were expected to be less than 1 kilometer from each other when communications with the ground was restored at 9 a.m. Moscow time. Instead, they were 40 kilometers apart. It required 2 more orbits to refine the tracking of the spacecraft and recalculate the necessary rendezvous maneuvers. By 12:40 in the afternoon of October 15th, Soyuz 7 and 8 were 1.7 kilometers apart, and the crews began the manual rendezvous maneuver without the Igla docking system. But the task, using only the approach and orientation engines and not the main orbital correction engine, proved too difficult, and the relative velocity was excessive. The 2 spacecrafts passed each other at 500 meters of range. In the evening, the same day, Soyuz 6, which did not carry Igla, was maneuvered to a distance of 800 meters with Soyuz 7, using a control panel in the orbital module of Soyuz 6. After the landing of Soyuz 6, there were 2 further attempts to dock Soyuz 7 and 8, but they failed, due to large errors in the ballistic calculations of the maneuvers necessary to correct their orbits. So no rendezvous due to the failure in the rendezvous electronics. There was only a successful approaching. The exact problem is still unknown, but it is often quoted as being a helium pressurization integrity test problem. The version of the Soyuz 7K-OK spacecraft used for the missions carried a torus-shaped docking electronics equipment housing surrounding the motor assembly on the back of the service module. This was thought to have been pressurized with helium to provide a benign environment for the electronics. But since the service module was ejected before re-entry, it could not be examined on the ground. At the time, the U.S. Central Intelligence Agency did their own investigation of the mission of Soyuz 6, 7, and 8. The CIA report was a little different than the Soviet version. Here is an excerpt from the report. The 5 rendezvous attempts made during the mission were all unsuccessful for several different reasons. The first failed because the automatic rendezvous system, Igla, would not indicate radar lock-on between Soyuz 7 and 8. 2 orbits later, the first manual rendezvous attempt was made, but it was broken off after Soyuz 8 used more than the authorized amount of attitude control propellant. A second manual attempt made the next day failed because Soyuz 8 did not properly control its lateral velocity relative to Soyuz 7. The attempt by Soyuz 6 to carry out a cosmonaut-controlled rendezvous with the 2 other spacecraft failed because of insufficient time to correct for a 3-kilometer out-of-plane separation between it and the other vehicles. The final manual attempt at rendezvous and docking between Soyuz 7 and 8 was poorly timed, and the vehicles could not establish the correct interval and relative velocity between them required for a docking operation before they entered the Earth's shadow. End excerpt. In addition to the operational program of autonomous navigation and manual maneuvering, the Soyuz 678 mission had a heavy program of scientific observations and investigations. This program included geological and geographic photography and observations, photography and observation of the spectral brightness of the surface of the Earth, meteorological observations, and photography and measurement of horizons for determination of the structure of the atmosphere. Other studies included photography of celestial bodies and studies of micrometeor erosion, luminescent particles, and cosmic and solar radiation. Which brings us to the Soyuz 6 first welding in space experiment. The Soviets believed welding in space would be needed for the construction of large orbital stations, as well as for repair of vehicles which had been in space for long periods of time. Furthermore, they believed that the weightlessness and vacuum of space would create ideal conditions for industrial production of super pure metals. The specific purpose of the welding experiment was to determine the peculiarities of welding under conditions of space and to investigate methods of welding that would be most useful for the construction of large orbital space stations. To accomplish these experiments, the Soviets constructed the Vulcan device. The Vulcan device was a completely automated device consisting of two major units. The first unit had various welding devices and a turntable with samples of metal to be welded. The second unit consisted of 1. An electric power pack, 2. A protective shield which covered the welding unit, and 3. A remote control console. The Soviets stressed that the Vulcan device was strictly experimental, not an operational tool. The experimental sequence began when Shonin, the commander of Soyuz 6, sealed off the hatch between the orbital module, where the Vulcan device was, and the descent module, where Shonin, Kubasov, and the control console for the Vulcan device was located. After the hatch was sealed between the two modules, the orbital module was depressurized until space-like conditions prevailed in it. Then, Kubasov initiated the automatic welding using the low-pressure compressed arc method. After this, he tested the electron beam method of welding and finally the consumable electrode type of welding. These operations included the welding of thin sheets of stainless steel and titanium. After this, the cutting of stainless steel, titanium, and aluminum was carried out by means of the Vulcan device. The experiment also included the welding of non-metallic materials and observation of the behavior of drops of liquid metal and of the welding bath in the weightlessness. All of these processes were carefully monitored by Kubasov from the control panels by means of TV. The Vulcan device could also be controlled from ground stations by means of telemetry. After the completion of the experiment, which was performed during the 77th orbit of Soyuz 6, the orbital module was repressurized. The hatch between the two modules was opened, and Kubasov then carried out a handheld welding operation using part of the Vulcan device while Shonin photographed his performance. This experiment was conducted to determine the most efficient procedures for hand welding in weightlessness. While performing the handheld welding test, the cosmonauts discovered that the Vulcan device's low-pressure compressed arc welding test had inadvertently targeted a beam on the orbital module's wall and had almost burned through it. Fearing the orbital module might rapidly depressurize at any moment, the cosmonauts retreated to the descent module and resealed the orbital module. Fortunately, the hull remained intact, but it served as a warning about the harshness and complexity of welding in space. Later, Kubasov quickly returned to the orbital module just long enough to grab the welding samples. Upon further analysis of the samples back on Earth, it was determined that the weld quality of the titanium-aluminum alloy and the stainless steel samples was comparable to welding performed on Earth. After a flight of almost 5 days, Soyuz 6 returned to Earth on October 16th, landing successfully at 9:53 Universal Time. A recovery helicopter landed 10 minutes later, finding the cosmonauts had already emerged from the capsule. Soyuz 7 returned safely 1 day later on October 17th at 9:25 Universal Time, and Soyuz 8 returned safely 1 day later on October 18th at 9:09 Universal Time. After the mission was complete, the Central Committee of the Communist Party, the Presidium of the Supreme Soviet of the USSR, and the Council of Ministers of the Soviets issued a joint statement summarizing the achievements of the Soyuz 6, 7, and 8 mission as follows. Quote, 7 Soviet cosmonauts completed a broad program of work in solving important and practical problems necessary for the perfecting of techniques of piloting spacecraft and the creation of orbital space stations of scientific and national economic significance. End quote. No mention was made of the failed docking attempts. General Secretary Brezhnev stated that the Soviet Union had an extensive space program calculated for many years. He added that Soviet science had decided that the creation of long-term orbital stations with replaceable crews was the main route into space for man. Salutations from the foothills of North Carolina. This is Michael Annis, your host, and I wanted to say thanks for listening to episode 234 of the Space Rocket History Podcast, entitled Soyuz 6, 7, and 8, Part 2, The Vulcan Device. Hope you enjoyed this episode. It was a pleasure to bring it to you. First of all, I want to apologize for mispronouncing probably most of those Russian names. And I want to give a big shout out to all my longtime listeners. Thanks for staying subscribed, and extend a warm welcome to my new listeners. I'm glad you're here. And if you are a new listener, you may not have heard this. There is a RSS feed for the first 27 episodes of the podcast. You can find it on the homepage on the right side of the page. This means that the first 27 episodes are once again available on iTunes, Stitcher, Google Play, and all your favorite podcatchers. My server plan allows me to add 100 megabytes of episodes per month. So, I plan to get some more archive episodes up in December, and eventually we'll catch up and close the gap entirely and have everything available through RSS feed. Today, we salute the most popular level of donors, and that would be the Apollo level. There are 77 so far this year. Apollo donors contribute $50 or more during the calendar year. Thanks for your continued support, Apollo donors. I had a couple of afterthoughts. What did you think about the Vulcan device? I thought that was pretty cool. It kind of sounds like something that could come out of Star Trek. Like something Mr. Spock would invent, a Vulcan device. But seriously, it was a real thing for testing different methods of welding. And it was the first time that welding was performed in space. Congratulations to the Soviets for another space first. And the welding experiment provided more evidence that the Soviets really were planning on building space stations. But to me, the Soyuz 6, 7, and 8 mission was mostly a failure. The Soviets failed to accomplish the most important objectives of the mission, docking in space. The Soviets had already accomplished docking with Soyuz 4 and 5, so the inability of Soyuz 7 and 8 to dock seemed to me as a step backwards. But in the state-run news outlets, the Soviet leaders chose to accentuate the positive aspects of the mission, such as the science investigations, performing the feat of having 7 cosmonauts and 3 spacecraft in orbit at the same time. And the Soviet leadership chose to totally ignore the fact that docking was not achieved, and they kind of left out that there was a near disaster during the welding test. Keldysh, the president of the Soviet Academy of Sciences, in response to a question from journalists, explained that the Soviets had a broad program for investigating the planets and for the creation of an orbital station. He also explained that for the time being, exploration of the moon and the planets would be performed with automatic equipment, and added that the USSR does not plan to send man to the moon in the immediate future. Okay, I'm going to interrupt Keldysh for a minute and say that at this point, Keldysh neglected to mention the reason the Soviets weren't going to send anyone to the moon anytime soon, which was the failure of the N-1 carrier rocket. Keldysh continues, the current major goal of the Soviet manned space flight program is the creation of a large permanent station or platform in terrestrial orbit. He explained that the mutual maneuvers, the group control of 3 spacecraft, and the success of the welding experiment have brought closer the day when the Soviet Union expects to have a station in orbit. He added that he expected such a station to be in orbit in less than 10 years and probably less than 5. End quote. To me, it seems that the failure of the N-1 and the high cost of the Soviet moon program and the American successful landing on the moon led to the Soviets changing their goal to orbital space stations. Eventually, the Soviets will tell the world that they never had a moon program. Now, certainly the Soviets will continue with their space program and overcome the setback of Soyuz 6, 7, and 8, and they really will put up orbital space stations just like they said they would. Okay, I have posted some pictures and the audio for this episode on my homepage, spacerockethistory.com. I hope you check that out. I was very pleased to receive several new donations to support the podcast over the past week. Andrew S. from British Columbia donated at the Apollo level. Eddie M. sent in another donation and moves to the Vostok level with his rocket emoji. Craig H. from Australia donated at the Vostok level and earned his rocket emoji. Stephen G. increased his pledge on Patreon to the commercial level, and Questline pledged on Patreon at the Vostok level. That brings our total Patreons to 147, the highest number we have had so far. Of course, our goal is to reach 150 by the end of the year, and we are 3 short. Will we accomplish this goal? Maybe. Patreon charges are made at the first of each month. Sometimes we lose a Patreon as the new month begins, but there have been many other times when we have had 100% retention. Anyway, we will find out next week. Our total donors this year, that is Patreon plus the one-time donors, have reached 299. That is 1 short of the goal of reaching 300. I believe we will exceed the number before the end of the year. For those of you who are enjoying the content provided here and have not donated yet in 2017, please consider supporting the podcast if you're financially able. Keep in mind, Space Rocket History is entirely listener-funded. There are 3 ways to make a donation. You can go to the homepage, spacerockethistory.com, and click on the orange Donate button to make a one-time donation. Or, if you prefer, you can become my patron at Patreon by clicking on the Patreon link located just below the orange Donate button. Or, you can mail me a check. To do that, just email me, Mike at spacerockethistory.com, and I will give you my address. I haven't mentioned this in a while, so let's talk about longevity rewards. When you make a donation to the podcast, your name is proudly displayed on the donors page at the website. Those of you who donate 2 years in a row receive the coveted rocket emoji next to your name. 3 years, you get a moon emoji, and 4 years, you get a satellite emoji. Now, this is a special time of the year. At this time, you can perform what I like to call the emoji maneuver. Let's say you haven't donated this year. If you make a donation now, before the end of the year, and make a donation in January of 2018, you can earn your rocket emoji beside your name on the donors list in less than 2 months. Or you could become my patron at Patreon now, and in January, you would automatically earn your rocket emoji. The emoji maneuver. It's fast and clever. Okay, let's continue. For those of you who have already donated for 2017, I certainly appreciate it. I have an item to give away this week to one of the 2017 donors. It is the NASA 3 1/2 inch diameter meatball sticker. To select a winner, I gave each donor a number, and I put the range in the Google random number generator and got the number for Igor Podgornov. Igor, if I mispronounced your name, I'm very sorry. Now, Igor, if you would email me, Mike at spacerockethistory.com, tell me your address, and I will mail out this lovely NASA meatball sticker. I have several more of these stickers as well, and we'll have a new drawing for the 2017 donor group next week. I was pleased to see that the podcast received 6 new 5-star ratings on iTunes over the past week. I would like to thank Yoga Matt for the very kind review and giving the podcast the all-important 5-star rating. And I would like to thank the 5 anonymous people that gave the podcast a 5-star rating as well. I appreciate you taking the time to do that. Thank you. This is the end of content for the episode, and you are welcome to stay and listen to my off-topic thoughts if you want. Thanks for sticking around, folks. I hope you enjoyed that episode. Next week, we will return to the United States and begin the Apollo 12 series. You don't want to miss that. In personal news this week, I have been looking for the Apollo Saturn V Lego kit for several months now. Wayne and Naomi sent me a link that he used to get his for $119 on the Lego store website. Now, I have been checking that link every day since, I guess it's probably been 3 months or more, every day, and it always says Saturn V was out of stock. And I tried other stores like Amazon and eBay, and their prices were like $50 more than the $119. So, for the past several months, I have checked diligently the Lego website. And I thought, well, maybe on Black Friday, it will be back in stock. But I checked again then and could not find it. It still said out of stock. But by chance, on Black Friday, Mrs. SRH was checking Amazon for deals and found the Apollo Saturn V for $119. I couldn't believe it. Of course, I purchased it immediately, and it is on the way to the foothills as we speak. I checked the price of it today, and it was $157 plus $12 for shipping. So the Black Friday deal was pretty good. I'm planning on assembling it with 3 of my 4 grandsons. And number 4 is not quite old enough to help with the assembly. Anyway, we're going to assemble it together and display it in the SRH Podcast Studio. Okay, that's all I have for this week. I hope to have episode 235 posted by next Thursday. So long for now.